Thank you. All right. Well, thanks very much for the invitation. And the list of awards simply demonstrates that bribery still works. So, okay.
Do we need lights off?
I got that first slide. Where did it go? Oh. That happens to me all the time.
So we put it into slide.
Questions? Thanks. Shortest one, the most succinct talk I've ever given. I don't go any near technology because I can turn it into a shambles. Oh, great. So can these, lights go off so this can, I can fade into the background. Just to, whoa. No, you can fall asleep in safety now. Just don't let your head hit the desk too loudly because that encourages other people to do the same thing. So it's really a okay. So environmental change across the Canadian Arctic Archipelago. I'm trying to do a blend of science, and I'm trying to also show some of the history and also just some of the general environment and people that I've been involved with. And as the preamble to the talk went, really I think it's the whole collage of experiences in the Arctic that do transform the individual, or ought to transform the individual, such that in the end you draw away from something with something much more substantial than just the science. I will be able to see. There we go. Yeah. So I just throw this in for all of you that have done field work. How do you pull together a talk on several decades, 4+ decades of Arctic science? And I put this in because it's from an old book on the 300th anniversary of the Hudson Bay Company. Maybe Bill Barr might be the only one who would recognize, but it was done by Kildare, Dobbs, and Robert Searle, and it was really a satire on the Hudson Bay Company. And I've taken one of Robert Searle's drawings and put in everything from twin otter pilots to fuel caches and tent-destroying winds and stratigraphy and enigmatic ice sheets, the whole mix of things that I was thinking of when I made this talk. So why study the past? I'll just run a few introductory comments. Clearly, we study past ice sheets, sea level change, ocean currents, and so on in order to document the nature of long-term environmental variability. And we need that because we must put modern change in that perspective if we're going to come up with a meaningful insight. And so I just show a few shots here of glaciers in the top left, and also sea level change. Here I'm fumbling in the dark. Sea level change, modern day sea level change, and I emphasize the influence of modern day sea level change as expressing the history of former ice sheets. So global perspective, the northern hemisphere, everywhere that is red, the land is rising relative to the sea, and everywhere it is blue, the land relative to the sea is sinking. And you can see that in all areas where there were former ice sheets, especially North America and Northern Europe, the land is still rebounding substantially in response to that unloading. So you might say, well, why study an ice sheet from 10 or 20,000 years ago? But it's largely, it's the predominant influence on modern day sea level change on a global scale, and it's fundamental to the geophysical input of models. And relative sea level change is very practically rising in many parts of Canada, in the extreme western Arctic and also the eastern Arctic. And so I just said, proper stewardship requires paying attention, being vigilant. So early days, I just think simply glaciation has not been studied very long relative to sea level change. And I think it's interesting when we look at the map here, we can see Louis Agassiz in the Swiss Alps back in the 1800s on his expedition. I thought, look at Louis. I mean, he's like in, shoes and spats and long-tailed jacket and his top hat and sketching away while they're making him, I think, Coquille Saint-Jacques in the background. But this is really quite classy fieldwork, but it's really the heydays of understanding ice sheets. And it was Louis Agassiz that brought the concept of glaciation to North America from Europe, from his early initial studies in the Swiss Alps. And this is sort of a postcard map of Canada from the 1960s, something put out by the Geological Survey of Canada. And you can see the Laurentide ice sheet to the south, the big ice sheet centered over mainland Canada. You might make out Hudson's Bay there. The Cordilleran ice sheet here. And then really not much understood about the high Arctic, which is going to be the focus of my talk and the career that I spent traversing the Arctic archipelago, trying to unravel the nature of environmental change. And this is the part of northern Ellesmere Island where I started my PhD, and I'll return to that, and simply a shot showing many of the large active outlet glaciers today. So a lot of enigmatic components to Arctic Canada, and here we have in the center a polar view. That's the North Pole right there. Again, Greenland, and there's Hudson Bay to provide orientation. And what you can see here is a map showing very expansive ice sheets. Again, the Laurentide and the Cordilleran ice sheet, and then they actually name the ice sheet over the Canadian Arctic Islands, the Inuitian ice sheet. And this little green dot is quite interesting because it's going to be the focus of my summary of the last decade of research that I've conducted that really challenges that model that green would be ice-free, little small area of ice-free land in the middle of the Arctic islands. And what you can also see, just to give you a general sense of the paleogeography, is that during the last glaciation, say 18,000 years ago or so, relative sea level was lower around these ice masses, at least, or at some distance from the ice masses, so that Bering Strait was exposed, and you had the Bering Land Bridge, or Beringia, extending from Russia across into Alaska and the Yukon. And just again, shots of some of these components to the modern day landscape, of course, glaciers. Here, you can't quite see it, but I'm holding a top off a Eagle brand box from Peary, and it says store in a cool, dry place. And it's very apropos for the Arctic until recently, and I think that's something I'll return to at the very end, reflect on the nature of change. It's not such a cool, dry place anymore. Sea ice, obviously a big story, and the role it plays for the fauna. And also then some of the Eocene redwoods, 55-million-year-old Dawn redwoods on Axel Heiberg that are not lithified, and about 2 to 4 million-year-old wood on Banks Island that we were looking at only a year or two ago. That's a rooted tree that's being exhumed out of fluvial gravels. Both of these, you could chop them up and put them in your fireplace and not know that you were dealing with 2 million-year-old or 4 million-year-old wood on the right and 55 million-year-old wood on the left. And I just throw this in to give me perspective because this is where I started in the 1960s, and I say flying precariously in old things, which is not a bad description, because these old prop planes used to lose engines, and there's dozens of stories that anyone that's worked in the Arctic could tell about aircraft. And this one, in fact, I was on it just before it crashed. I got off at the last Douline site, and it proceeded on with some big Caterpillar engines strapped with chains on the floor. We had been sitting right in front of them, and the site we landed at, where I got off, we had failed to get into the week before, and we had traveled elsewhere and stayed over the weekend. I got to know the pilots reasonably well. And then when we headed back, I was to stay with the plane if it did not land where I was able to get off, if the fog was still there. And the friend of mine and I got off at that site, and NAD, I can still remember the call signal of the aircraft. It proceeded on, and it flew into fog and icing conditions outside of Cape Dyer, and the pilot, very veteran pilot, flew it in blind, and he hit a very low hill, hardly a hill at all, just in the line with the strip. And sadly, then everything in that aircraft went right through the fuselage. So they didn't stand a chance. But we traveled around in these beasts, and I'm thinking back on the days we used actually piston propelled helicopters. And what was interesting in those days, we tied everything on the floats. You'd put everything inside a Jet Ranger now, but everything, paddles, boats, tents, tent pegs, whatever you had, one on the floats, and you lash them down, and myself and one other and the pilot would be in there. So we were very fortunate not to have any serious accidents. And this is where I started and really started to fall in love with the Arctic. I was in my really not even first year university. I did a preliminary year, but I got up onto Baffin Island for 3 months and did a whole range of things with some very interesting and inspiring mentors. And so this was on the Decade Glacier. You can tell by the vintage of the Skidoo that this is not your normal BMW 400 horsepower Skidoo. It's like 8 horsepower, and I think it was strong enough to carry me up there and no one else. So we're just doing some study of the mass balance of the glacier. And I spent my 18th, 19th birthday on the Barnes Ice Cap. The Barnes Ice Cap, for those who don't know, is a little remnant of the Laurentide ice sheet. So if you're right in the center of Baffin Island, about 100 kilometers long, 60 kilometers wide, and numerous stories with the people there. We would have sleds and with skidoos and sleds, and we used to, Doug Hodgson's very tall, and I and Pat McLaren would drive 2 different skidoos, and John Clow, as a geophysicist, was monitoring the radio echo sounding, looking at ice thicknesses in a box built on top of one of the sleds. Doug was on the other sled, standing upright like a telephone pole, and we used to play this game where suddenly John Clow would pop out of the frame of his machinery, his equipment, with a lasso. He was from Nebraska. He was very good with a lasso, and I or Pat, whoever was driving the other sled with Doug, would pull into position, and invariably John would lasso Doug on the first try, and then somehow or for some reason the 2 skidoos would diverge. Doug's eyes would dilate, and yeah, I'm sure I've got years in purgatory for that. But Baffin just was a beautiful place to start. And we used to listen to the radio every week, and there was CBC Northern Service used to read letters, and they used to announce the letters on the radio over the CBC Northern Service that was being read out of Montreal. And they were always really bizarre, strange little stories, like how was the garden doing, and Jim and Bill passed grade 10, and they'd go on, and they'd announce them like 4 or 5 days ahead. So we wrote a letter. I decided I was going to write a letter to myself. I'm the parent, I'm writing, and I changed my name to Robin Angleterre, and I think Ihor was my sidekick. And we wrote this letter, and that time we'd give our letters to a pilot who would fly eventually to a DuLine site, and on the DuLine they'd take them bilateral, and then eventually they'd land up in Winnipeg where they got stamped. So obviously our parents were writing from Winnipeg because they'd stamp it in Winnipeg and send it to Montreal. And we told everybody we're going to come on. Eventually we might get our letter written, and it did. It came on. They announced it like 3 days ahead. I think it was Mike Church who radioed us, said it's on tomorrow night. So we all listened in, and it was just totally facetious. But the guy that read it, it was so serious. He would read it in this very stalwart, monotone voice, and it went, "Dear Robin and Ihor." We are so sorry to hear about the amputation of your arm following the polar bear incident. So we had the guy's arm amputated and gangrene had set in, and we had to cut off a little more. And then the next paragraph literally went to, and Aunt Betty's garden is doing very well. The peas are, and you know, we had Dwayne failing grade 10 for the third time, and then Aunt Lucy went out and bought him some tools to go down and work at the local machine shop, and we just poured it on. And the guy read it in absolutely this serious voice, while you could probably think of camps all across eastern Baffin Island at that time cackling away. So we were mischievous from the start. So, but very easy, as I say, to be enchanted by this environment. A lot of people started their careers. I think field work's so important that way. A lot of people, Mike Church in that last picture was also involved. So off to Ellesmere Island. So I started my PhD. After all that undergraduate work on Baffin, I did my master's student work there, my master's thesis, then went up to Ellesmere to start my work there. And I really didn't know much about it. And I've told the story where I went into a bank in Ontario, in Toronto, and I asked for traveler's checks, and the manager of the bank insisted that I take traveler's checks in American currency because Baffin Island was in the United States. And I looked at his wall map, and there was nothing of the archipelago on his wall map. It was gone. It was so classically Canadian. So, and I had the great opportunity to work with someone who's become a dear friend for many, many years. We've worked in the Arctic together, Ray Bradley at the University of Massachusetts. And I was so impressed that he owned an aircraft at that time, had Bradley written on it. Actually, this is DHT, and I go now in the very deep water. And I've mentioned it before, but it struck me when we were making such a fuss over the Russians putting down a little plastic flag from Walmart down on the bottom of the Lomonosov Ridge, and we were all sitting there, you know, festering about sovereignty and ownership of the seafloor and, you know, the United Nations Convention for the Law of the Sea. And I said, well, why don't we make more hay of the fact that we put a twin otter down? We put 2 twin otters down. They put a plastic flag. Do we ever hear us get on the radio and go, that's nothing? We put like a $1.5 million twin otter down there. So Carl Berg landed DHT on some sea ice back in the 1980s. It went through and everybody got out okay, but the twin otter continued down into like 4,000 meters of water. So that's what the early days on Ellesmere Island looked like, starting my PhD. And Ray Bradley and I sledded over rotting sea ice. Neither of us was very experienced with sea ice. And I pulled Ray, who was sitting on the Nansen sled, and I was on the skidoo. And every time we punched through areas of rotting ice, I'd turn around and see Ray skimmering over the top of the fractured ice with his eyes popping out of his head. So we were very fortunate. But the whole area is rich in history. I was very fortunate to go up at this time. And as you'll see, find historical notes and so on. But there's a collage of things here. But obviously, the early exploration into my PhD area, or the early exploration by late 19th century explorers, was such that people were terrified of being frozen in, at least for more than a year, when their supplies would be clearly running low and ill health would set in. And in that area, just hiking across the plateau, I came across the grave of Niels Christian Peterson. That was a Danish sled driver for the crew of the HMS Discovery, and he was going across over to the Alert, which was not far away from where his burial site is. And this is what many of the explorers would obviously erect, are prominent cairns signaling ships coming up, in this case Nares Strait from the south, that the ships were in the area, so that if there was a relief crew coming in search, that they would have some indication that they were on the right track. And I walked towards this one, and a big white Arctic hare came out from behind the rock and hopped away on his hind legs, as they do. And I walked up and read it, the memorial to Hans Christian Petersen, and at the bottom there was a line out of the 50th Psalm that said, "Thou shalt wash me and I shall be whiter than snow." And I sort of thought, wow, that Arctic hare, maybe. And so when I started my PhD, I was on Northern Ellesmere Island, and Ray and I sledded to the historic site of Fort Conger, which was the site of the first polar year. And this is where Greely and his men were from 1881 through to 1883 when they abandoned the site. And they were brought north by the Proteus out of St. John, Newfoundland. And this is a wonderful book, 3 years of Arctic service, summarizing Greely's experiences. And if you were there today, within the new national park, you would see the buildings that Peary erected when he took apart Greely's house and built these 3 smaller sheds. And Fort Conger today, again, you can see the original building, but this is the outline of that. The 3 buildings I showed you are right behind the viewer, but the bedsteads and the barrel hoops and rusted masses of congealed nails, like little surrealistic porcupines, I always think of them, where people have taken the barrel staves for wood for burning. And this was the little barrel hoops that you can see piled here were also used in this case to outline a garden that the cook built back in 1881. It's still there. I think it's an incredible paraglacial experiment because it's very much like it was in the original drawing that you can see of them. It's not that they're falling over. They were originally in that orientation. So over 100 and almost 20 years ago. And during that time, we climbed a mountain offshore. So right off Fort Conger is Discovery Harbor that we sledded down, and a small island, Ballot Island, and on the top of Mount Campbell. We hiked up one day to have a look and see what we could find in terms of the Quaternary history. Greenland you can see right across. In fact, we stopped up there for lunch, and we're standing in a beautiful day, probably 12 degrees, sunny, calm, no bugs. And what happened as I was sitting there getting into my tuna fish sandwich, by my heel of my boot, just beyond it, there was this brass cylinder sticking out of the rocks. And we obviously opened that up, and there was a note from Captain Stevenson of the Discovery, and the note that was put there. And it just, one of the things says we lost the sun on the 16th of October, 1875, that they were up there in 1875, 76 and overwintered until 29th of February, 1876. And they lost 2 people who succumbed to scurvy on the other side, over on the Greenland side. But what's interesting, when I got back and read Nares, I wondered why no one had found a note previously in the cairn, because they came up in 1875 and left in 1876. Greely came up at the polar year in 1881, about 5 years later, stayed there for almost 3 years, and his men would routinely climb this mountain just to get some exercise and so on, and visit the cairn. They even described repairing it after a strong storm in one of those visits, and yet never found the note that I found. And so when I got back, I read that Nares was required to leave 2 notes, one in the cairn itself, which I don't think anybody's reported, and the other one would be due south of the cairn, or sorry, due north of the cairn. And due north of the cairn magnetically was basically at that time due south. So we were facing south, looking at Greenland, and that's where that note was. So that was very exciting. Ray Bradley, who I was with at the time, many years later, only about 4 or 5 years ago, was in Britain in a small little village, found the book that Stevenson wrote upon his return and purchased it. And when he looked inside of it, it said, "To my dear mother, from her exploring son, Captain Stevenson." It was his book, signed by him and given to his mother, that only Ray Bradley could find. And that was a note next year, sledding down one of the fjords. This was from the International Polar Year. And I just thought, I was reading it last night. Okay, so I've got to read this out loud, because I thought, talk about being to the point. This record, because this is left by Lockwood, and there's 2 notes. This is the outer note, And the inner note was a long handwritten note by Greeley, and they're in the National Archives now. And he goes, "This record is deposited here this 15th day of August, 1882, by the subscriber who left Fort Conger August 13th with 5 men of the U.S. Army in the steam launch Lady Greeley for the purpose of reaching this vicinity, etc." I went, wow, if only we could write like that. And then below he's got the record left by Lieutenant Archer of the Royal Navy was taken by me. That was, but the long note inside really was quite interesting. All the meteorological observation neatly and tightly written, mean monthly temperatures and so on. And Greeley actually describes leaving photographic plates in the note, and he didn't. And you can't believe for an academic how good that felt, to know that there he is in a little hut in the middle of nowhere, with the only sound probably is the ticking of his clock, and he's absent-minded. He forgot to put them in. I was like, oh, good man. So while I was up there, all these ingredients, all this beauty, really convinced me to write a letter in 1972 from St. Patrick's Bay requesting that Parks Canada consider this as a national park. At the end of that summer, they did send somebody up briefly, and then I continued to propose this, and then in the early 1980s, they hired me and a few others to conduct the first natural resource inventory of this area and draw the boundaries for what is now Kitten-Arpak National Park. So I was very happy. I reflect on that and think that's one of the contributions I'm proud of. So after this early work, my PhD was on Northern Ellesmere Island. I came south and all the way down this coastline, really following the footsteps of Greeley, because Greeley was under orders to leave Fort Conger regardless if in the 2 succeeding summers supply ships didn't reach him. And they obviously didn't. As anyone is familiar with his history, he was then forced by those orders to retreat southward, expecting to find supplies down here and reaching that point with 25 men after about 3 months of perilous boat journey in the steam launch Lady Greeley, and finding that he would have to go through the winter of 1883-84 with virtually no supplies. If you have a pen and pencil and you can think of a book worth reading about this expedition, it's The Ghosts of Cape Sabine. It's written by Leonard Guttridge. Is a fantastic synthesis, I think, of all the various journals, diaries that were being kept by the people. There were near mutiny on the sea ice. One of the people I had near the end of the expedition had to be executed for stealing food. There's so many different ingredients that people kept taking basic scientific observations even under the most abject conditions. So The Ghosts of Cape Sabine is an absolutely great read, written about 10, 15 years ago. And Greeley even describes coming down between an enormous floe, probably an iceberg that had split in two, and they didn't know what they would do. The sea ice everywhere else was so severe, they went through this passage, and that's what's portrayed here. I traveled down with Dave Burgess and James Hooper in various places, and spent 3 or 4 years on the East Coast. And while I was doing that, many other people were complimenting my work. My PhD students, Rod Smith, who's in the back and previously with the survey and now just with Stantec here in Calgary. So Rod and I worked, well, he did his PhD on the Hazen Plateau, and we worked together further south as well in '95. And Trevor Bell, who's now at Memorial University, did his PhD on the Fosheim, and then Colin McCuffick, who's now a professor at Durham University in the UK, did further work south. And eventually we're really going to move right across the archipelago, but this took 35, 40 years of surveying, as you'll see. But I just wanted to emphasize that while I was keeping my own work going, there were really quite enormous contributions being made by a team of very talented graduate students. So throughout all these seasons, we're starting to put the landscape together. We're not just eating sandwiches and finding historic notes. We're surveying and leveling in or determining elevations on former sea levels and mapping glacial landforms, moraines, and meltwater channels, just trying to reconstruct what did this place look like 10 or 20,000 years ago. Where was the ice sheet located? How did it operate dynamically? And when did it retreat? And the ice sheet that basically subsumed the entire landscape from expansion of modern day, or what were equivalent to modern day ice caps, little ice caps on the uplands, that subsumed landscape was depressed enormously by that weight of ice. And with the removal of that ice, the land bounced back. Yes, sea level rose, but the land rose much faster. So sea level rise was like a slow elevator, and the land rise was like a fast elevator. And so the net result is that sea level, shorelines at the time of deglaciation, when the ice was first getting off the land, shorelines formed very high above present. And as the land came up faster than the sea regressed or dropped down to where it is today. And you can see like step-like fashions here of those successive lower shorelines as the land rebounded. And we would measure the height of those, because how high it bounced back, or how high those shorelines, deglacial shorelines, were, is a kind of a measure of how much unloading of the crust there was. So it's indirect measure of how thick the ice was. Obviously, the thicker the ice, the greater the rebound. And the timing of when that ice physically got off the landscape was recorded by the first entry of marine shells, which we would often collect and then radiocarbon date. So literally thousands of observations on shorelines and thousands of radiocarbon dates on marine shells and driftwood and so on were put together regionally to reconstruct the retreat of the ice sheets. So what did we get? Basically, if you can orient yourself here, the ice sheet that covered the Canadian Arctic Islands, there's Ellesmere and Axel Heiberg, and there's Prince Patrick and parts of Melville. That ice sheet is the Inuit ice sheet, and it subsumed the whole landscape. The darker gray is more mountainous areas. This lighter tone is modern day ice caps, and the land is the gray. And the black lines are where the ice was the thickest. If you were going along, that would be the ridge crest, if you want, of the ice sheet. So these are also places from which the ice flows, so they're called divides. And so you can see a complex of divides, all feeding one big ice sheet, both in the eastern Arctic, which is very mountainous, and in the western Arctic that is quite low. And from those divides, there are areas where ice converged and formed ice streams. You can see the arrows here. So this sort of gives flesh and bones to the ice sheet. This is sort of the skeleton, the configuration of it, and that these complex of divides and so on, which are based on our measurements and our mapping and so on, describe real flow lines and real coverage by that ice sheet. Inuit ice sheet met the Greenland ice sheet in their strait, fittingly green, and to the south, the red is the Laurentide ice sheet that would have covered all of mainland Canada. And then, basically in a nutshell, this just shows in different colors the retreat of the ice sheet based on the entry of marine fauna, the shells and shorelines that I described. And the ice started to retreat about 11,000, and you can still see that it's still quite dark blue. Even by 8,000, there's still quite a bit of ice left. And the white is the modern day ice caps. Probably the ice retreated inland of where the modern day margins are about 5,000 years ago. But that just gives you a sense of the ice sheet. And I mentioned the shorelines. And so when the ice sheet retreated and the sea invaded, it crossed the land, and we've surveyed those shorelines. So basically the oldest shoreline in this area is about 8,500 years old. And these red lines, this sort of thumbprint pattern, is simply contours drawn on the 8,500-year-old shoreline. Shoreline used to be flat, and then because the land is rebounded, in some places very substantially, and in other places less, that shoreline is now deformed or de-leveled. So when you go to the margins of the ice sheet, the rebound, the shoreline of 8,500, is basically right at modern sea level. But as you go to the former center of the ice sheet, you can see that shoreline rises to 20 meters, 80 meters, all the way up to 130 to 140 meters in Eureka Sound. So this thumbprint of, if you walked up that shoreline, 0 to 140. That 140 meter shoreline shows you this is where the ice was previously the thickest and rebounded obviously the most. And one of the interesting implications of that is not only can you talk about modern sea level, because areas like this are still rebounding, areas out here would now be submerging. So that it's relevant if you're a community out here, like Sax Harbor, your community, your coastline is rising, the sea is transgressing. Same down in Frobisher or Iqaluit. But if you're probably in Grise Fjord or even Holmen or Ulahaktak as it's called now, you're closer to the former center of the ice sheet and the land is still rebounding. So it has practical implications for modern sea level change, infrastructure, and so on. One of the interesting things is these channels today are relatively shallow. The Arctic island channels are only about 150 meters deep. And water from the Arctic Ocean travels southeastward through the archipelago to the North Atlantic. And what's interesting is that about 8,500 years ago, the sea level, as you can see, was 140 meters higher. So today, most of the water coming from the Arctic Ocean is a freshwater surface layer. So this is the modern day surface sea level. And these are the sills. And the sills, as I mentioned, in the channels are only about 150 meters deep. And that's the thickness of the surface water coming out of the Arctic Ocean, the relatively fresh or less saline water coming out of the Arctic Ocean, moving today towards Baffin Bay. And the deeper and more saline and warmer Atlantic water can't get through the archipelago today because of these sills, because that water's down about 150 meters plus, so it just bumps into the sills and can't enter. But when sea level was 140 meters higher, then obviously we had about 150 meters of water more above that sill depth. And now you could have both the surface water going south and the Atlantic water going north. And we've just done a whole bunch of cores down in this area from the Bedford Institute. And you can see that really prominently during the early phases of deglaciation. And the fauna in the dinoflagellates and the forams and so on show you that when the water was deeper, you had Atlantic water coming through, and then as soon as the rebound continued and made these channels shallower and shallower, just as it took land above modern sea level, then that Atlantic water was excluded. Axel Heiberg, towards the end of the work in the high Arctic, this is where we worked, a beautiful area. Quick story, Bob the Wolf stole my master's student's boot. She had one pair of boots, left them outside her tent. Eastern Axel Heiberg Island, boot is gone. She had only runners, weren't adequate. And so they get on the radio and talk to me, and I go, we got to get a pair of boots. So I radioed down to Resolute Bay and asked them to get some boots. Resolute Bay says, no, the closest place boots of this size is Yellowknife. Phone down to Yellowknife, get a pair of boots, onto a jet, jets up to Resolute, from Resolute Bay into the Twin Otter, 2 hours up to southern Axel Heiberg Island, into iCamp, into the helicopter, an hour up to Katrina's camp, new boots. We look around, Bob was there, we call him Bob the Wolf. That's my boot out of focus. If you lie down and look sufficiently innocent, they come walking up to you to check you out. So he's very close. The boot is not in focus because I didn't have the right focal distance. That's my leg shaking. No, so he came up and then he left. The next day, we took the helicopter back down to my camp. Katrina gets on the radio. The Wolf brought the boot back. The day after, the Wolf brought it back. She had both her boots. And I have interrogated the student who was with her. And while we were on that camp in southern Axel Heiberg, boot stolen there, we came across remnants of what we believe was Hans Kruger's camp. Kruger was lost in 1930. The last note found was by Ray Thorsteinson on Little Mean Island here. Kruger had come across from Greenland with a companion and a Greenland Inuk, and they came through Sverdrup Pass, and they went counterclockwise around Axel Heiberg, following what was Peary's previous travels in the early 1900s. And somewhere in this area he had left a note that was found at Cape Stallworthy by the RCMP, by Captain Stallworthy. And then Raythor Steinson found the note in the 1950s. After that, he had disappeared. So we were down here, probably another 300 kilometers further south, and we found this scrap of material. We had been looking for Paleo-Eskimo sites, or none on western Axel Heiberg, which is interesting. And we came across this, just a few objects that immediately caught our attention. And so we went over to check them out. And we came across, Art Dyke and I came across a little transit, like a level, a surveying level. And on the ground, the compass that would go with it, separate from the instrument in a beautiful wooden box. So we spent a lot of time, through the help of an individual at the Museum of Science and Technology in Ottawa, and finally tracked this instrument down to Max Hildebrand, and this would be the compass and similar model, obviously. And we found out that this particular model was probably made about 1925, just a few years before Kruger went to the Canadian Arctic, and Kruger had been living in Greenland, so obviously he had bought it previous to his trip in 1930. So anyway, it was kind of the remnants of Kruger's camp, which was really quite exciting. But then after that, really, there isn't any trace. So also little hand collections of stones on the ground and so on. So we really think he was clearly using that camp. But then he would have disappeared after that. And it did look almost like the camp was set up under duress. So my last decade really of work has been with this Northern Research Chair. So if we come out of the high Arctic and land up in the Western Arctic, the previous model of this area was that ice sheets didn't cover all the land. So during the last glaciation, grounded ice would be this lighter tone. Floating ice fed from this were wrapped around Banks Island, for example. This is the Mackenzie Delta. Because the ice sheets weren't very thick here and weren't depressing the crust substantially, relative sea level was lower than present. So you can see the islands were slightly bigger. Prince Patrick and Mackenzie King were joined at that time due to sea level being, say, 20 or 30 meters lower. And Banks Island and Melville Island were pretty much ice-free. And so that was the model. But this really stood out because most other areas of the entire Laurentide ice sheet and the Inuitian ice sheet to the north indicated really pervasive ice during the last glaciation. So it wasn't clear, just like that little green dot on that first map I showed you at the beginning, why would there be ice-free areas in the Western Arctic? So that's what we investigated, and in a nutshell, we found that the ice inundated the entire landscape. So here's the previous map. You can see Banks Island. This is just a larger version of that same island. This island is left largely ice-free. That was also the model from the Geological Survey of Canada. All these different colored greens, lighter, mid, dark, are glaciations that are progressively older in this direction. This green would be over 800,000. This would be like 100,000. This would be like 80,000. And basically no ice on the island during the last glaciation. And indeed, this little red bit was believed to be ice-free. And at the time of drawing this map, we transformed the reconstruction. We have ice completely occupying Banks Island and running out, grounded ice running out through the channels, not floating ice, and a local ice cap worked by Chantal Nixon and also Doug Hodgson on the uplands of Melville Island. So we have basically pervasive ice. This ice would be streaming and warm-based, bit of warm-based ice through here, mostly cold-based ice. And this whole idea of a ice-free landscape, we actually, about a year later, went back the next summer, and out on the ice-free landscape, we found meltwater channels full of glacial erratics from mainland Canada, from the Canadian Shield, and from mafic erratics from upstream on Victoria Island, just filling these little valleys. So although much of the landscape does look like it had never been touched by glaciers, it was cold-based ice and went over it. And when that ice retreated, the meltwater streams from the cold-based ice incised that landscape. So we've completely replaced this model of many, many glaciations and a very old record with one of very extensive ice during the last glaciation. And why is this important? Well, the Europeans have been doing some very interesting work, and North Americans, but basically here's the Canadian Arctic. This coloration is the Inuitian ice sheet and the Laurentide ice sheet, and these are first efforts to describe these blue lines where there were within the ice streams, rivers of fast-moving ice embedded in relatively slow-moving ice. So these ice streams were conduits of a lot of sediment and ice to the Arctic Ocean. And what they find in the Arctic Ocean is that the seafloor has been scoured. This first came out about 2002. Leonid Polyak and others started to describe flutings, actual flutings on the floor of the Arctic Ocean and water depths up to 1,000 meters. So the first time you hear this, you're really incredulous because it blows apart your conventional model of what ice sheets can do or how thick they were. So somehow there was floating ice or icebergs that was thick enough to scour the seafloor in 800 to 1,000 meters of water. Some of these flutings are quite widespread and pervasive. There's other places where they wander more irregularly, which would be more typical of the keel of an iceberg floating, whereas the really strong lineations are really cohesive, grounded ice, presumably ice furrowing the floor. So our work in the Western Arctic now, if you can see the Western Arctic here, Banks Island and so on, here's Victoria, Banks Island, we're sending ice, our reconstruction, about 14,000 years ago, out onto the shelf. And that big ice 14,000 years ago is just what really the Europeans need for thick ice to scour the floor. We're calving ice, breaking off bergs, and we know some of these ice streams from the mapping we've done are probably over 700 meters thick, maybe up to 1,000 meters thick. That's the thickness of ice of an iceberg they would need to go out into the Arctic Ocean and scour the ocean floor. And we have this ice retreating. The blue margin is just, that's the maximum limit, then about 14,000. It's just a series of panels that show you the ice retreating from northwest to southeast. And it's interesting, two things go on here. As this ice retreats, what's interesting is the Bering Strait, which was previously exposed, the Bering Land Bridge goes under. And we know that from a little shell we found in northern Ellesmere. This little shell, Certidaria curiana, comes from the Pacific Ocean. And it arrives about 13,500 years ago. And it's the first shell to arrive in this area. And it clearly requires Bering Strait to be resubmerged. And that's considerably earlier than previous models. So the ice sheet is retreating rapidly. There's lots of meltwater coming off, say around 14,000, and shells are coming in 13,500. So not only is meltwater coming from the ice sheet, but the Pacific Ocean is roaring back in to the Arctic Ocean as well. And that, I think, is interesting because if we talk about glaciers being stable today, relative sea level rise, a couple of meters would be devastating if you lived in coastal India or Bangladesh and so on. And during this time I'm talking about the ice sheet retreating, there's been a very prominent interval of sea level rise. So this is 16,000 years ago, and this is about, say, 13,000. And you'll see that sea level is going from about minus 120, let's call it, 16, 18,000 years ago, and sea level is rising, rising. And right here, there's a very steep rise of sea level of about 15 to 20 meters. Goes from about 105 meters, 110, up to about 90 meters. So there's this abrupt jump in sea level. It's called meltwater pulse 1A. And people have previously ascribed it to Antarctica, all the work from Antarctica now says no, not much going on in Antarctica. There's no substantial reduction in ice volume. So this really substantial rise in sea level, I think the Laurentide ice sheet has never been considered. It doesn't mean the Laurentide ice sheet did all of it, but our rapid retreat is in this very time interval, and I think it has to be regarded as a contributor. And that just shows this guy standing on this, what about glaciers breaking up the Antarctic ice shelves or drawdown from the Antarctic ice sheet or retreating glaciers anywhere, and he's got the high tide mark there. So it does speak to other issues that people are working on, and another issue is Ray Bradley and I, again, with this flush of meltwater from our retreating glaciers, the return of the Pacific water, the Barents Sea ice sheets out of the way, so the Atlantic water's coming in. This is all around the time of an enormous cooling in the North Pacific called the Younger Dryas. So we're suggesting that the Younger Dryas, this big cold event in the North Atlantic, was triggered by the release of this sea of ancient ice. So during the last glaciation, when ice sheets were surrounding the Arctic Ocean, we would suggest that very severe temperatures from ice core records and elsewhere suggest that there was very severe sea ice on the Arctic Ocean, and the reopening of Bering Strait, retreat of the Laurentide ice that we've now documented, and so on, has mobilized this very thick Arctic Ocean sea ice, and that's what invaded the North Atlantic to cap the North Atlantic with cool, fresh water, and that would be something that would have sort of global impact. So this is the Arctic Ocean sea ice. It gets exported out at this time, and it goes into the North Atlantic, and it acts as a lid, a cool surface water, fresh surface water, that will prevent the existing heat pump that we're well familiar with today. The North Atlantic Drift or the Gulf Stream comes up the coast of the US and crosses over to Europe, and then that water cools and sinks and returns as a cold current at depth. And by invading the North Atlantic with cool fresh water, Wally Broker and others hypothesized that that would shut down, would prevent the overturning of water in the North Atlantic, and it would shut that heat pump down. It would shut the warm air, the warm water going north and the cool water going south, and really cause an abrupt cooling of the northern hemisphere. And so many people have hypothesized other solutions to or causes, but Ray and I are really the first, I think, to invoke the removal of the Arctic Ocean sea ice, which has a lot of capacity to get to southern latitudes. And I'll just skip over this because it's towards the end of the sciencey bit, and I just end with a few reflections. But I've talked about this regional retreat. What's interesting is this blue is the ice. It retreats back to the southeast corner. It gets right down to this southeast corner from about 14 to about 13,500. Very fast retreat over about 500 kilometers. And this is slightly different orientation and scale. But if you can see this purple or blue line coming back and standing in the very bottom of the corner here, that's this dotted yellow line. The ice gets back there at about 13,500, let's call it, and it sits there for 1,000 years. And it's almost like it had this enormous collapse, sits there for 1,000 years, and during that 1,000 years, it must re-thicken. And it's re-thickening during the Younger Dryas, during this cold interval. So the preceding warmth, the ice calves comes back, stabilizes on the land all through the Younger Dryas. It's almost like the earlier stage of retreat was the bellows is emptying. If you just think of squeezing a bellows and all the ice going out of the ice sheet and the divide lowers. And now during the Younger Dryas, you suck in air into the bellows again, and the ice sheet is thickening. That's the bellows recharging. And after about 1,000 years, right at the end of the cold Younger Dryas that lasted about 1,000 years, boom, you squeeze the bellows again, and out comes very vigorous ice that covers this entire area. And there's an ice stream about 100 kilometers wide that just subsumes this landscape, rakes it with landforms, and when it hits the ocean, that ice floats and forms an ice shelf, a big floating ice shelf, very much like the ones we have in Antarctica today. We've mapped the ice shelf going across the channel, and it gets from here to there, overrides shells here about 10,000 years old, and pushes shells up over here onto the land that are also 10,000 years old. It happens, this event, 400 kilometer advance, is less than the standard error on a radiocarbon date, which is basically like a human lifetime, less than a human lifetime. So, and it forms an ice shelf 100,000 square kilometers in area, and it forms prominent, like you run a highliner around the coastline if you look at it on a satellite image. So this is a dramatic landform, some of the probably the most spectacular ice shelf moraines anywhere on the planet. So the ice was way back here, it re-advances, it's grounded to about where the lighter toned is. That darker area is all floating ice, and it goes, that's about 100,000 square kilometers, and that little red dot on Northern Banks Island is this very prominent moraine. And this is all marine sediment that got shoveled up as that big floating mass of ice went on shore, because sea level was at the time a little bit, well, here's sea level today, sea level was back in here, and so it's still floating and grounding up and stopping offshore with a little moat of sea in between the grounded margin and the land, and it bulldozes up marine sediments and overfolds them. We have all kinds of radiocarbon dates that all around that margin say that this all advanced on shore at the same time. So ice shelves, really, this is what's interesting here, is that that ice shelf lasted 400 years, and it's being fed by an ice stream that's 80 kilometers or so wide, or 100 kilometers wide, about a kilometer thick, and maybe it's going about half a kilometer per year forward. So that's, if you do the math, it's about 50 cubic kilometers of ice for as much as 400 years. So what does that mean? That means that bellows, which is squeezing out that ice, is diminishing. There's not much air, there's not much ice left in the bellows. So the divide that's feeding this ice shelf is thinning and thinning and thinning. And that divide is the main, it's like the heart, it's like the main muscle of the northern Laurentide ice sheet. And as it atrophies, finally, this ice shelf catastrophically breaks up. So I said it formed in less than 70 years, less than a human lifetime, sits there for 400 years, and it breaks up in less than a human lifetime. So when it breaks up, what's left of the Laurentide ice sheet is desperately trying to replace it, is drawing down, it's thinning more, and the sea just tears into this ice sheet. So when the ice shelf goes, it's like lighting the wick on a piece of dynamite. And that wick, as the ice shelf goes and the margin of that breaks up and retreats back, the boom, the explosion, is when the sea goes right through the Laurentide ice divide.
Is it unexpected that your evidence suggested such a quick turnover, such a quick growth, and such a quick disappearance? Is that where you think it's going to be really implications for Antarctica?
Well, this is...
change can happen that quickly?
Yeah.
Without climate shifts?
Well, yeah. So if I go to this... Did I zoom too far? Those are the Antarctic ice shelves that you're referring to today, the Ross and the Fletcher and others. So these are really big ice shelves, and they basically buttress the land-based ice. They're kind of holding back the interior ice. If you remove those ice shelves, then there's strong drawdown into the ocean, and lots of people have speculated that the West Antarctic ice sheet, WAI, is clearly it's grounded below sea level, and if you remove these big ice shelves, does it sort of catastrophically, in effort to replace them, draw down into the ocean and provide maybe 6 meters of sea level rise? And I think what we're saying is that we have an analog here for really the catastrophic breakup for modern day ice sheets. I mean, this has happened, and this was really I think this is probably the best geological record of a former ice shelf anywhere on the planet. And so, I mean, Reed Bryson used to say what has happened can happen. So it doesn't mean that's what's going to happen, but I think it's very instructive to know that it can happen. And not only did I just describe that ice shelf, But beyond it, way out here, during that rapid retreat I described earlier, there's beautiful ice shelf moraines. These moraines are so much like shorelines, you have to get down on them to see their moraines. I've literally said, if an ice sheet tried to forge a shoreline, this is it. So these ice shelf moraines are like forged shorelines, and there's a whole series of them. So when the ice retreated rapidly earlier, it floated. It was grounded, then it floated. It retreated as an ice shelf. It re-advanced as an ice shelf. It broke up as an ice shelf. So ice shelves are a huge part of the story in understanding the Northwest Laurentide ice sheet, and they're instructive in terms of a modern warming world about what is the vulnerability or the importance of the vulnerability of modern ice shelves. History followed me everywhere. This is Winter Harbor, and beautiful rock here. And this was inscribed by Perry in 1819 when his ship came through. He almost made it through. He would have been the first person to discover the Northwest Passage. That was really going to be McClure's glory when he stood in northeastern Banks Island coming in from the west, and he could see where Perry reached 30 years before him, so he knew there was a continuous channel. So in 1850 or so. This rock is beautiful, and here's Canada's testimony under Wilfrid Laurier, Prime Minister Laurier in 1909. Bernier, Joseph Bernier came up here in the Arctic, and he pounded in a plaque. And I think it's one of the most elegant expressions and one of the only expressions of Canada's kind of really strongly assertive act of sovereignty. And it says, it's beautifully inscribed, it talks about the taking of possession of the whole of the archipelago from like 70 degrees north all the way to the pole, and from longitude in eastern Canada to longitude in western Canada. And it says, taking possession for the Dominion of Canada, the entire Arctic archipelago lying north of America. And if you go there, up in the upper corner, there's somebody came along with a penknife, and it's like Ben Smith from Seattle. Respect. It's a really iconic place. And in the same area, when we were at Cape McClure in 2010, they discovered the Investigator, the ship that McClure had, and abandoned in 1853 or so. And that's in 30 meters of water, really quite remarkable. And the whole crew escaped and went back up towards Melville Island. The crew got out traveling eastward with some other ships who were in that area. So some concluding thoughts. I apologize for dragging on. But here I just feel to talk about Arctic landscape, there's a lot of things I take home from all this. One, we way over-exaggerate what glaciation has done to the landscape. We turn glaciers into these ripping mammoths that, produce enormous events, changes in the landscape. And looking at them, you think, okay, that's possible. But you might have seen a paper by Catherine Lafarge who talks about the bryophytes, the mosses coming out from underneath one of these retreating glaciers that are still intact and have been regrown from 400 years ago. So my feeling is we turn glaciers into these sort of geomorphic Tarzans, and here he is swinging out of the woods onto an Alberta clear cut, and yeah, he's naked and he's not doing much other than going down. And so just a quick cartoon, people think, the Canadian Arctic islands, the channels between the islands used to be rivers and they were carved out by glaciers. We go to find the sediments and we don't. So there's the idea of these glaciers going down the channels, just rip deep, deep valleys, 500-600 meters deep. There's a huge number of reasons why that isn't very palpable. But at the same time, left islands ice-free that were much lower. And then now we find, though, rocks, huge rocks up here on the north side of these channels. So why would ice from the Laurentide ice sheet go ripping out down these channels, be like you being a bowling ball finding a deep, deep gutter? You're going to follow that. You're not going to climb up the side and go over an intervening landmass. So the ice preferentially goes down these channels, perhaps. But then how do you get this rock from way down on mainland Canada way up here to the north. So one of the options I think we're starting to return to and have a lot of new evidence for it is that the glaciers didn't carve out the channels. The glaciers crossed this entire area before the channels formed. And they dispersed erratics, in this case bones. Hagar's throwing these bones out across the landscape. They dispersed them with complete indifference to the modern day topography, because that topography wasn't there. And so what do we find? We find now more and more evidence that across from one island to another island, there are fluvial, there are channels, there are river channels that cross this island and continue on the next island, and evidence in places where those river channels are actually on the intervening floor. So the only way a regional river from mainland Canada could go from island to island and leave traces of itself on the floor would be if that river crossed a contiguous landmass. It had not yet, the block had not yet been driven down. And what's interesting is that there is not a hiatus between the rivers that crossed what had to have been a contiguous landmass and the first arrival of glaciers. So if you go to the upper deposits from the rivers, called the Beaufort Formation, you actually start to see within the Beaufort, the upper Beaufort, glacially influenced sediments. So that the regional rivers crossed the pre-faulted landscape, so did the first glaciers. And we would argue that the channels certainly later received ice and focused ice, but that ice, the style of ice through time has changed in concert with the very young tectonic evolution of this area. And I had argued earlier that the faulting actually stopped regional glaciation, but that certainly is not the case. We do find that channels have been filled by glaciers. There have been shells transported onto from one side of a channel to another onto the land, clearly indicating ice did at one point, later stages, advance through marine channels, or what became marine channels. But I think this is important because I think what it's saying is that how we think of landscape, how we think of environmental change, even on the long term, is still poorly understood, and it may still be full of surprises. Tons of other surprises. We're getting rid of the ice shelves on northern Ellesmere Island. These are the oldest sea ice in the northern hemisphere. This is what they look like in the late 70s. They've been actively breaking up since 2000. They were very extensive when the explorers were there in the end of the 1900s. About 10,000 square kilometers in the late 1900s. About half of it survived up to about 1960. And since 1960, almost all of it has been removed, and most of that after 2004. So these are beautiful ridges and troughs. You're looking tens of kilometers here. And these ridges and troughs are formed on ice about 40 to some cases 80 meters thick. And when it breaks off, it forms ice islands and drifts around the Arctic Ocean. And what we did is we collected driftwood on these coastlines. When was the last driftwood in from Russia, coming right across from Russia to Ellesmere Island? When was the last wood in before these ice shelves formed? And the last wood in is about 5,500 years ago. Those ice shelves formed. The wood could no longer reach the coastline. And wood has never been able to reach that coastline in the last 5,500 years until now. And it's in the last decade or two we're really seeing the core of these ice shelves disappear. Think of your thumbnail and then think about cutting it back to the quick. We're at the quick now on these ice shelves. So these are modern changes. And that's the ice shelf from a satellite image. There's the pack ice. The ice shelves were doing really well. Everybody's heard about pack ice diminishing. Well, pack ice is like one person leaning on the shoulder of another. They're pushing each other. Pack ice is bolstering the ice shelves. Severe pack ice, strongly developed ice shelves. Get rid of the pack ice, you stop buttressing the ice shelves in the warmer weather, and they start to fracture. And the ice shelves in 1906 were everywhere on the north coast, and they've just gone right down to Zippo. And this is the core of the Ward Hunt ice shelf around Ward Hunt Island. There it is again. You see the open water, you can see the fractures. So we're losing these ice shelves at an unparalleled rate. Glacier ice in the Western Arctic. There's lots of glacier ice still buried under the ground in the Western Arctic. Here's David Evans leaning over. There's some surface material. That's glacier ice. All this till on Banks Island is over buried glacier ice. Buried glacier ice is melting out on Banks Island. Lots of concern about this in Sachs Harbor, producing these big retrogressive thaw flow slides. So we're in the air. This is probably about 200 yards across, 200 meters by probably 250 meters, similar. These are recent failures. That lake is muddy with the debris coming out of that. So the ice underneath is melting, and this veneer of sediment is just sliding over it into the sea. And this, so all these melting permafrost, disappearing ice shelves. And here's a grizzly bear. No one has seen a grizzly bear this far north since we found one there in 2005. And he's been seen several summers since. And you talk to the communities of the Huktuk and Sachs Harbor, lots of bears, normally on the northern mainland, on the tundra of northern mainland Canada, are now getting over across Victoria Island, all the way across the sea ice, another 80 kilometers onto Melville Island, getting onto Banks Island. The Inuit find them, they shoot them because they don't trust them, and they come off the sea ice surprisingly hungry. And a friend of mine in Sachs Harbor was charged by one just 2 summers ago, and they shot it obviously right before them. So it's really, I think these are, you know, really dramatic things. And I've been arguing for a policy. How do we keep Canada interested in the North? We have no polar policy. I just have been lobbying. We need one. The Americans have one. It's generated unbridled support. We're disorganized. We don't have a vision. We don't have committed resources. And we don't need to, because there's nothing that holds our hand to the flame. We have a northern strategy, but if you've got a northern strategy and you're any one of number of government, federal government departments, I might be Fisheries and Oceans, say, yeah, let's do this in the north. You're the Department of the Environment or another agency, and you can say, well, sorry, we're not going to put money there. The Americans have mandatory cooperation between agencies in their northern science policy. And it starts off by declaring the United States as a polar nation. We still haven't done that as a country. It's disgusting. So here we are, Canada. I use this as a metaphor. This is Bernier's hut, 1909, Melville Island. Looks great from the back. It's a metaphor for our lack of commitment in the north. You come around the front, and it's about 6 meters from this eroding coastline. This is part of our history. So Captain Bernier's hut is there. The door's off the hinges. There's no windows. There's 2 meters of snow in there. And I just feel, you know, and not more than a kilometer away, it's this triumphant statement by Bernier, the taking of possession of the whole of the archipelago for the Dominion of Canada. And that was under Laurier, and I don't think there's been a prime minister since that's been anywhere near as close to doing something. A lot of support, a lot of graduate students, a lot of friends and family. Wish I could tell you more stories, but I landed up giving a talk to a grade 1 class in École Émile Tremblay in Whitehorse, and I gave them this little talk, and in the afternoon, 3 or 4 hours later, from memory, they drew pictures. So when I got inducted to the Royal Society of Canada, that's what I showed them. I went, here's where it's at. Younger people being many of you in the room, and the really young, got to convince them that we have something very special to celebrate. Thank you.